Hi there. Today we're going to be talking about integration. This is a Core 2 Chapter 12 Edexcel chapter. So you should have done integration in Core 1, and we're going to be using integration to find out the area below curves and in between a curve and the x-axis. So what is integration? We know that integration is the opposite of differentiation in the basics, and we know that to integrate a value, what you must do is plus 1 to the indice and divide the indice by the entire thing. So for this integration, which we're finding the area between the curve and the x-axis, we will use the statement the curve BA, which are showing the values, and insert, and the dots here are representative of the value. Then we integrate the statement, we integrate it and put it in square brackets. Before it was curved brackets, and now we integrate it and put it in square brackets. Once we have integrated it, we use B and A, B being this one and A being this one, and they split part for B and one part for A, and we'll use them. So let's go through this example. First of all, we've got the integration sign, and we've got 2 and 1, 3x squared. So we know that we're going to have to plus 1 to the indice, which is going to be 2 plus 1 equals 3. And then we're going to divide it by 3. We're going to divide it by 3, so 3x to the power of 3 divided by 3 is going to equal x to the power of 3. Now, we substitute in the values of 2 and 1. If we put 2 cubed equals 8, and 1 cubed equals 1. So 8 take away 1 equals 7. Okay, so I'm going to pause the video. You can pause the video here and try this one. Okay, you're back. Now we see integrate for 1. So we're going to apply the same thing. First of all, we're going to write it out, and then we're going to integrate it. And integrate it, we're going to plus 1 to the x value, which makes it 2x. We're also going to plus 1 to this indice value, and which makes it 3 over 2. And then we're going to divide it by the given indice value that we found, and we're going to find the integrated value. So 2 divided by 2 equals 1. So it's going to be x squared. And 3 divided by 3 over 2 equals 2. So it's x squared. Very easy. And we substitute in the values of 4 and 1, and it's quite simple. It looks very hard, but it's actually very simple. So you can have a go and pause and have a go at this. You're back. So we put it into square brackets and integrate the value, adding 1, and as always, and you notice this was a 1, but we made it into a 2x to the power of 1 over 3. Okay, and you notice that once again we'll split it in, we'll sub in the values, and then you add or minus them together. There's 2 minuses, so it's going to be plus 3.1. As shown. Now we're going to use it to find the area under a curve, or I'd like to say between a curve and the x-axis. So a curve and the x-axis, and remember that we used b, the right hand side, as the top of the integrated value. So a and b are the limits, and remember that b is the upper limit and a is the lower limit. Okay, so thank you very much. And once again here, so we have them in this form, but to find what they are as x, it would be x would equal -2 or x would equal 4. So, and then remember, we put the, now we're trying to find the area between y and the x-axis, between the curve, the y and the x-axis. So now we have 3 things involved, and so we'll be using, because it's the x, because it says between the y-axis and the formula, we'll be using the upper boundary of 4 and the lower boundary of 0. So first of all, we expand the bracket as shown, and then we integrate the bracket, and then we sub in the values. Subbing in the values, which is, it is actually much simpler than it first seems. So you can pause and have a go at this. Okay, so we can see here that the x value 3 is obviously above the x value 1. So x value 3 would be the upper limit. And so, as you can see, it is the upper limit. What do we do? Say it with me. Integrate. Rewrite and integrate. Now it's important to rewrite first before you integrate, because rewriting is, for me, there are no many other students, it helps them see it better, and I would fully recommend you using that, because it does help you see it better, I think. So yeah, and we integrate, and then obviously we split and substitute. So there are 3 steps, or 4, including rewrite, integrate, split, and substitute. So we substitute in the values. It gives us a nice number. Once you put them into your calculator, it gives you a nice value. And there are some calculators that will do the integration for you. However, you will not get marked. You cannot just use this key and write your answer. You need to use calculus and show you're working, or you will get a maximum of 1 mark. You should use this key to check yourself, but not for it entirely. Okay, so you should know that. Okay. Now it's very important that you write it as a third form. You write it as a fraction or a third form. So it's much more important. And obviously, if it is, say, 6 over x squared, write it as 6 to the x minus 2. Now rewrite it is very important. So have a go at this. Now this is a new part, and we're trying to find, what we're going to have to do is we're going to start off with a sketch. And because we look at the values, it's going to be obviously plus 3, the boundaries are going to be plus 3 and 0. So obviously 3 is higher than 0, so 3 is the upper boundary and 0 is the lower boundary. So we're going to look at this sketch. It's going to look like this. It's going to have 0 and 3. And this time it's below the axis. So although area does not take into account minus, although we will have to say it is a minus, it is under the axis. So first of all, what we're going to do is we're going to expand the bracket. And as you can see, 3 is the upper boundary, 0 is the lower boundary. We're going to integrate it, so what we're going to get is x to the power of 3 over 3, and 3x to the power of 2 over 2. We said rewrite or expand, integrate, split, and substitute. Remember those. So we're going to split and we're going to substitute. It's fair once you get into it. I actually really like integration. It's one of my favorite parts. You'll really like it. I really like it. My students like it, so I think you will do the same. So now look at this. Now we know that the values of x are going to be 0, -1, and 1. So we'll go -1, 0, 1. So like I said, -1, 0, 1. That's very nice and easy. Start off with a sketch. I would really recommend doing the sketch. If you don't do a sketch, it's going to be hard to visualize it. It helps you visualize it. For this time, you have 2 parts. And personally, well, not really personally, you should be doing it in 2 parts. So I like to call them A1 and A2. So if you were to do this, first of all, what do we say? Expand or rewrite. First of all, we're going to expand the bracket to x squared minus 1, the difference of 2 squares. We're going to expand the bracket once more, x cubed minus x. And then we're going to integrate the bracket, as seen. And then we're going to separate, split, and substitute. Split and substitute. Remember, split and sub, split and sub, split and sub. And we found out this is for the part above. So this is A1, as I said. And now we're going to work out A2, which is part under. So we've got as the upper boundary 1 and the lower boundary 0, because this one was the other time we had the upper boundary of 0 and the lower boundary of -1. So we're going to first of all integrate, which we've already done. And we're using the rewritten or expanded bracket that we had. We're going to split and split and substitute, split and substitute. We're going to put them in and it'll get us an answer. And then calculate it, and then we add the 2 areas together. And it's very important that you don't forget to do them separately as 2 areas. So as we said, the total area would therefore 1 squared, because 0.5 to 0.5 units is obviously 1 square. So now we need to know and calculate the area between a curve and a straight line. Now this is very important. The way we do this is through the trapezium rule, and you will be given a question on this in your quarter exam. I most definitely think that there will be one on there, and we use this equation. And the way in which we do it is sometimes you will need to work out the values of A and B, because you don't know the values of A and B, and so we have to do that before by working it out from the equation. So from the equation we can see that x is equal to 0 and x is equal to 4. So let's see. As we said, x is equal to 0 and x is equal to 4. And there is the straight line here of y is equal to x. Okay. And what we're going to find is we want to find the region R. And the way we're going to do it is find if y equals x and y equals x bracket minus 4 minus x, then x is going to be equal x bracket 4 minus x. So that's where we're finding it, and we're going to expand the bracket, and then we're going to take away and accordingly, and subtract accordingly, and we've therefore found, in fact we're going to factor on it, and what this gives us is the values of x and 0 of the straight line here. So we know that, so x equals 0 and x equals 3. So x equals 0 here and x equals 3 accordingly. So this is almost kind of clear as though x equals 3, although I would not give a guess to it. So thank you very much for watching up to here, and I'll see you next time. Thank you.